Hi, I'm David Hornberger from the Virginia Tech Baja SAE team. We design and build a single-seat off-road racing vehicle every year to compete with universities from around the world. And our competition consists of a series of both dynamic and static events, simulating a real-world engineering challenge of designing and building a vehicle for production to be produced at 4,000 units per year. We have to make a sales case for this vehicle to show that it is a marketable option for a company to invest in. We have to present the engineering work that goes in, going through the entire engineering cycle, and then we have to use a series of dynamic events to prove the performance of our vehicle. The dynamic events typically consist of acceleration, hill climb, sled pull, maneuverability, suspension and traction, and they culminate with a 4-hour long endurance race where all 100 cars are on the track at the same time, and we're trying to turn as many laps as we can. If our vehicle breaks, we fix it, get back out there, and continue turning laps.
I'm Matthew Looney. I'm a senior in mechanical engineering at Virginia Tech. I'm going to talk a little bit about the drivetrain on the cars today. We use a 10 horsepower Briggs & Stratton engine that's mandated by SAE, and we can't modify it at all. From the engine, we go into our CVT, which shifts through gears similar to a transmission in your car, but it uses moving sheaves and a belt to change gear ratios. From there, we move into our gearbox. It's a 9-to-1 reduction through 2 stages. All of the case itself is machined in-house. The gears are made out of C61 barium with cutouts for weight reduction. Those are hobbed or wire EDM. And from the gearbox, then we go into our shafts, which power the wheels.
For our shafts, generally we run a steel shaft, but this coming year we're going to be looking into running a carbon fiber shaft that's bonded onto 2 steel ends. This section will replace the center section of this shaft that is shown, that goes from our gearbox, as Matt was saying, to our hub.
So the main project I work on the vehicle is our suspension. We use a non-parallel A-arm rear suspension as independents, and what that allows us to do is have each of the wheels independently travel 14 inches each. And the reason we want so much wheel travel is because it improves our capacity to keep the wheels on the ground. Without the wheels on the ground, the car cannot be stable and cannot transmit power in the forward direction.